Hello everyone, welcome to my channel INFY. So welcome back to another video. So here in this video we are going to build something interesting. We are going to build a game called rock paper scissor. I think most of you are familiar with this game. So we are going to build this game using MobX state management library in Flutter. So that's what we are going to build. So I will show you what we are going to build today. So basically this is the app which we are going to build. So basically here we will be having a screen where this screen is divided into two parts, where the left part is for the player and the right part is for the computer. So player will be having an option to choose his choice. He can choose rock, paper or scissor. So when a user selects a choice, computer will automatically randomly generate computer's choice and display it over here in this right part of the screen. So on the rock paper scissor logic, depending upon the logic, the particular player, whether it is the player or whether it is the computer, the score gets added. Let's say if I click on rock and computer gets the paper, so paper wins and computer score increments to 1. And if both the player and computer choices are same, like if the player choice is rock and if the computer's choice is also rock, then we are going to display a snack bar saying that both the choices are same. We will display a draw, and we will not give a score to either the player or the computer. So that's what we are going to build today. So we are going to use the core rock paper scissor logic here, and so for this we are going to use the MobX state management library. For those who are new to MobX, you can head over to this site called mobx.netlify.app. Here you can find the documentation and all. Basically on an overview, MobX is of three basic concepts: observables, actions and reactions. So observables basically contains your state, and actions are something which mutate or change your observables, and reactions are something like this snack bar. So we'll not go in much into details of the MobX concepts. While we are coding, we can understand what exactly MobX in what are its concepts are. And this is the exact package we are going to use. This is what we are going to use into our Flutter. So we will understand it much better when we start writing the code. So I have all the UI code written with me, so we need to only implement the logic part. So first let me go through the pubspec.yaml file. So here I am going using some dependencies. So I'm using the MobX package and Flutter MobX package as well for the UI part, like for the observer widget, and I'm using the provider package also to provide my store to the entire application. And in the dev dependencies I'm using two packages. One is the build runner and the one is MobX code generator for code generation purposes. So you can find all these things in the documentation while learning MobX and all. So these are the basic things for our project. And so basically this is my coming to the project structure. This is my project structure. I have screens, store, utils and widget folders. So in the screens folder I will be having only one screen where the only UI related code is present. So only UI related code is present in the screens folder, and in this store folder I am having this MobX thing. I am having this MobX store. So this store contains all our state, and this store manages the state for our game. So this is about store, and I am having this simple utils folder where we have all the constants required for our app. And for in the widgets folder I have divided the screen into three particular widgets. So as you can see, this is the screen. So the top part, the player and computer part, is nothing but your scorecard widget. So this is the scorecard widget. So I will walk you through the UI here itself. So widgets will be having all the widgets. So now let's start from the beginning. So this is my main.dart file. So here I'm having this material app. So in this material app I'm having the home as rock paper scissor game screen. So in this rock paper scissor game screen, I have this scaffold widget, I have this app bar saying rock paper scissor, and for the body I'm having a column, and this column has two widgets. One is scorecard widget, this is the column, this is the scorecard widget, and the second one is game area. This entire part is game area widget, and at the bottom I have this reset game widget. So first let me go through the scorecard widget. So this scorecard widget as a row, so it's a simple row having the player score and computer score widgets, two text widgets, player score and computer score. So that's all. This is only the scorecard widget. So after scorecard widget I'm having this game area widget. So the below of the scorecard widget is your game area widget. Basically this is a row of columns. So we have a row, and that row we have two columns, and this is the first column. In this first column we will be having three widgets. One is the rock image, one is the paper image, and one is the scissor image. So that is about the first column, and in between we are having a small divider just to separate the widgets. And in the second column is not yet implemented. Here we are supposed to display the computer choice image. So if computer randomly generates a rock, then we are going to show rock image here. So that is what the second column widget is. So basically this is all about game area widget. So now let's close this. So basically we are having scorecard, game area, and in the bottom navigation bar we are having our reset game widget. So in this reset game widget we have just only a simple bottom app bar. So one click on this we'll just call the reset game function. So basically that's about the UI walkthrough. Now let's get to the heart of this video. So now we are supposed to open our store. So if we go to the store, this is the basic syntactic this is the way we create a store in MobX. So this is the basic boilerplate code where I am creating a rock paper scissor game store, and all the remaining part will be handled by this MobX code gen library. So so I am having an abstract class where it is mixed with a where store is a mix into my abstract class. So I have to-dos listed down here. So first task is like we need to initialize our player score and computer score first. So we need to have two variables, one which holds the player score and one which holds the computer score. So those two variables are observables. So those observables are the state, like so whenever the value of those variables change, then your UI also must change. That means that variables contain state, both these variables, player score and computer score. So here we will be using the concept of observable. So I am going to say player score is equal to 0 is an observable, and next I am going to say computer score is equal to 0. So now we have two variables, player score and computer score, initialized to 0. So now let me remove this to. Now next we have to initialize player choice and computer choice, and before going to that, in my constants file have this app constants already defined. So loading constant is 0, rock constant is 1, paper constant is paper is represented by number 2, scissor is represented by 3. So these are the constants I am having right now. So let me initialize the player choice and computer choice. So I'm going to, so again these things are also observables here. So because when those are the state variables for us, we are going to say player choice is equal to app constants. So let's say by default it is rock, and similarly for computer choice we have let's say paper. For by default computer choice is paper. So we have completed defining the player choice and computer choice variables. Now we have the one more variable, one more state variable called is equal choice. So we need a way whether to let's say we need a variable to track whether both the choices of the computer and player are same. So if player chooses rock and computer also gives the rock, then there should be a variable to track that condition. So that's why we are going to say is equal choice. So by default it is going to be false. It is going to be of type boolean. So is equal is by default is going to be false. And now the next task is to initialize the total score getter. So we need a variable. So there is a concept called computed in MobX. So computed this is total score is dependent on these two variables, player choice and computer choice. So player choice minus computer choice gives you the total score. So basically that is a computed property. Why computed property? Because we don't need to take a separate observable. Our total score variable is dependent on two observables. If a variable is dependent on observable, then that is a computer type. So that's why we are going to say total score. So I'm going to use the factorial syntax and I'm going to say player choice minus computer choice. So that's about the total score variable. And the next task is to define the computer choice image. So our logic is like a computer will generate a random integer. So it could generate 1, 2, 3. So if a computer generates the integer 2, then here we need to display the paper image. So to get that particular image, we are using this computer choice image getter. So I'm going to write that logic over here. So if the computer choice variable is rock, then our image variable is going to be assets slash images slash rock.png. So I am going to repeat this same logic for the other three cases as well. So rock, paper, scissor, paper, scissor, and we are also defining the loading constant as well. So whenever a user clicks on rock, we are going to display loading image for a few seconds and then display the actual computer result. Rock, paper, for rock, paper, loading. So and finally I'm going to return that particular image path. So this is done, and now we need to write our reset game logic. So this is an action where action is responsible to mutate your observables. So I'm going to say both the computer choice and player choice is going to be 0. And now we have the actual method like play computer and is run is win. So whenever a user clicks, now let me open the game area widget. So now here we are having these three images, right? So this rock, paper, scissor. So whenever a user so here I'm having this game store. This is the variable where I can access all these properties using this variable. So this I am getting from the provider package. So provider gives me this RPS game store instance. So I am going to say game store dot. So I am going to update the player choice variable to the user choice. So here when the user clicks on the rock, then I am going to say the player choice is going to be the rock. And also we are going to say game store dot play computer method as well. So whenever a user clicks on rock, we are going to update the player choice variable in the store, and we are going to call the play computer method. So we are going to say basically we are saying I have chosen my choice, now it's computer turn to play the game. Now so I repeat this same thing for other two images as well. It is going to be the paper, and here it is going to be the scissor as well. So now that we have done, let us come to this store part. So play computer. So before going to the play computer method, let me go through the isDraw and isWin. So isDraw method takes two parameters, one is the player choice and computer choice. So here I have this logic chart. So basically this is the logic for the rock paper scissor. So these are the conditions. If both the choices are same, then it is tie. If it is rock scissor, win. Paper rock, player wins. Rock paper lose means player loses. So that is the condition. These are the conditions which we are going to implement. So I am going to say for the first, let us define the isDraw method. So for the draw conditions, we have three: rock rock, paper paper, scissor scissor. So this is the easiest part for us. If let's say if player is and computer is also app constants dot paper. So if the player chooses paper and the computer also chooses the paper, then we will return true. Okay, otherwise we will return false. So let me define the other conditions as well. And paper is done. Now rock, if both the choices are rock, if both the choices are scissor, then we return true, otherwise we return false. So isDraw method is done. So now let me define the win conditions. So win conditions are these are the win conditions, 1 2 3. We have three win conditions. So the first win condition is rock and scissor, and the second win condition is paper and rock, and the third win condition is scissor and paper. So if these are the conditions, that means the user has won, or else the user has not won. So we are done with the draw and win. Now the main core thing is the computer's logic. So for this we are going to say, let us say computer choice is going to be, let us say the computer choice is going to be loading. So we are going to say future dot delayed duration for 300 milliseconds. So let me wait for 300 milliseconds. So now let me frame the computer choice image first. Switch computer choice. Okay, first let's say int computer choice is equal to random dot. So now let me generate a random integer between 1 and 3. So now that is done through this random package. This will, so basically this is something where this is going to return a random integer from in between 1 and 3. So in between 1 and 3, random integer is nothing but your rock or paper or scissor. If computer uses 2, then computer chooses 3 paper. If computer gives us 3, then the computer choices scissor. So now depending upon the computer's choice, we need to frame our computer choice image. Okay, so here we are updating our computer choice. Okay, so that is done. Now it's very simple, just we are going to check the condition. If the player choice and the computer choice are equal, then we are going to say is equal choice to true. Otherwise, if the player choice and the computer choice, in between player and computer choice, if it is a win condition, then we are going to increment the player score by 1. Otherwise, then we are going to increment the computer score by 1. So with this, we'll also make sure that our is equal choice variable is set to false at the end, if at all, just to make sure. So I think we are done with the play computer variable. So I think okay, so with this we are done. Basically what we did is we have set computer choice to loading, and then we'll generate a random integer between 1 and 3. We'll set the variable to computer choice, we'll update the computer choice variable, we'll check for conditions, and accordingly we increment the score as well. So let me save this store. I think we are pretty much done with this store. Now let me go through the game area screen. So here we are remaining with one part. So add computer choice image observer with height 50. Okay, so here I'll be adding an observer widget. So here I'll get a builder. So this returns an image. I'm going to say game store dot computer choice image, and the height is going to be the 50, and remove this constant. So we are done with this game area, and we need to wrap our games. Let me open my game screen. Okay, so now let me run this. Okay, as you can see, the computer's images are changing, but not the scorecard. So let me open the scorecard widget, and yeah, so let me take an observer widget over here, because our observer widget is responsible to listen to our observable state variables. So here we'll be having our, let me take the game store instance. So here we'll be having the player score. Let me remove this constant variable, and here I'll be displaying the computer score. Okay, so this is done. Let me check with the reset game widget as well. So when I click on the reset game button, I'm calling the reset game. Basically just a second, let me open this store. So let me go to the reset game. Yeah, we are resetting the player scores. So let me run the app and check. So as you can see, I have okay, see both the choices are, I think the computer score should not increment here. Let me go through the logic. Okay, so this is the mistake I have did. So we need to use the OR condition over here. So it should be or not end. So let me rerun. Let me play now. So I'm selecting rock. Yes, I won, I got. So yes, yes, draw. Yes, now check me reset. I think reset is not working. So it should be player score and computer score to 0. So let me play. So now let me reset. Yes, it is working. So here, instead of setting the choices, we need to reset the score. So basically this is we have come to an end. So depending on these conditions, we have built this application, and as you can see, it is working fine. Yeah, so basically this is how we can build a rock paper scissor game using MobX in Flutter. Like, I've made use of all the MobX core concepts like observable, computed, and the action as well. And one more thing I would like to show is, like, in the game area widget, if I have gone to the screen, so whenever a tie occurs, then we are displaying a snake bar, right? So that is achieved through reactions. I have used the auto run, so it is depend on this equal choice variable. So if this variable changes, then this auto run will run, so then we will show a snack bar. So this is one I would like to add. So, and this is also available at my repository, so you can go to this URL and find this public repository, rock paper scissors MobX. So if you have any doubts, please let me know in the comment section below. So this is a wrap for now. So that's all. This is how we can build React applications with MobX in Flutter. So that's all. Thank you for watching this video.